Hello everyone, happy Friday. Happy Friday. Is it just me or this class feels a little bit smaller compared to last week? That's not a good sign. Okay, so how's your assignment going? Did you have fun looking for data sets? Haven't looked at it yet. Haven't looked at it. It's okay. Relax for another week. Let's start this weekend, yeah? We have an assignment for this module. We have 2 assignments for this module. Hi, Wu Jinwei. Can all group members use the same data set for assignment 1? Or do we have to find different ones for each? Everyone can have the same data set. Yeah? Everyone can have the same one. Every group members can have the same data set. Yes, I've chosen stroke prediction. Yes. That's a good one. Very fun. Yes. But very fun. Why is that tears? That's a happy tears, is it? Happy tears. Okay. Haven't started. Let's start this weekend, yeah? Hey. Who copied your topic? Maybe you can regroup as group members. This Sam, I'm cooked. Why are you cooked? Smiling in pain. Had your dinner? What are the criteria for complex data set mentioned in the assignment? It doesn't have to be too complex as what is mentioned, but make sure that it is sufficiently big, as in at least 5 variables, at least 2,000 rows, okay? Somebody asking for IG fans, IG followers. Please follow. Hello? Can our assignment 1 topic be the same as my group members? Of course, yes. They're supposed to help you, right? But you are supposed to produce the work individually, yeah? You can use the same topic, but you are supposed to do the work individually. Fraud detection. Okay, sounds interesting. Smiling through the pain. I'm good. Drop table machine learning. Drop table machine learning. What is that? Okay, so before we start the class today, those who are having practical class from 8:30 to 9:30, feel free to join the 7:30 class if you do not have a clash. In case you have a clash, I will still be conducting the 8:30 to 9:30 class. Yeah, same venue here. Okay. Hi. I'll be motivated by a smile. Okay. Will you be marking assignment first? Then only we can decide what data set to work on? No, unless you submit on week 7, then I will look at your assignment 1 first. Okay? The answer is no, yeah? Take note. Hello? Skibidi. Skibidi. What is this skibidi? You thought I don't know, is it? A bit confused about the table for related works, specifically the last few columns. It's okay. You can just start with the first few columns that you are not confused with, and we'll get there, right? Yeah? Any other questions? Especially on assignments. Feel free to ask them so that other people can benefit from your questions. Yep. Never going to give you up, never going to give machine learning up, right? That's a must-have skills. Never going to let you down, never going to let your machine learning down, right? Huh. If I bring you out on a date, will you give me an A? I'll give you an F. Love the way you teach. Thank you. You get more questions in the future, yeah? Can you bribe me 2 Coke for an A? No, you have to trust yourself. You can get A without bribing, okay? Deserve a W. What is a W? Is there a W? There's RCW. RCW stands for receipt coursework. How about 3 Cokes? No. No Cokes. Trust yourself. You can do it. Oh, that's a sad face. Well, okay. Time's up. (179) attendance. Is there 179 here? I don't think so. Oops. Sorry, my laptop refused to work. Hey, what happened? Sorry for the technical issue. Oh, yeah, there are more questions. If too hard, we're going to take, no. How about the company? Yeah. So yeah, let's start our class today. Sorry for the delay and for the technical issues. So recap, who still remember what we discussed last week? So last week we talked about supervised learning. There are two types of supervised learning. One type is regression and another type is classification. I think only one of your classmates have done the revision on the previous lecture because this person have reached out to me to check on one typo, a very important typo. Okay, so here I know who is reading and who is not. Well, there is one typo in the previous slide. I'll see who else can spot it. Yeah. So last week we talked about supervised learning, we talked about regression, we talked about classification. So then, the reason why we have been stressing on this supervised learning is because it is found to be one of the most utilized machine learning among the enterprise of the IT leaders. This is very, very important to learn the skills of supervised machine learning, especially in the machine learning area. Yeah, this is the reason also why we are stressing on supervised learning. So now this week we are going to talk about machine learning workflow. So how many steps does it take to build one machine learning model, to train a brain to do machine learning task? Okay, so this is the content of today's lecture. We will walk through the machine learning workflow. We will also bring you through some of the very important vocabulary so that to get everyone on the same page. We know that not everyone have done data science before, and therefore we just want to give everyone the same context before we get started with machine learning algorithm next week. Okay. Then we'll also talk a little bit about the principles of data wrangling. Ultimately, why do we need data wrangling and what is this for? So we want to talk about how do we handle some common data issues such as missing values as well as the outliers. And finally, we want to talk about exploratory data analysis, which is one of the very first step in the machine learning workflow. Okay, so first thing first, look at this entire pipeline. We see problem statement, we see data collection, we see data exploration and pre-processing, modeling, validation, and decision making and deployment. So this entire process is called the machine learning workflow. So for those who have not done any data science related course before, this is something that you need to know. Every machine learning workflow starts with a problem. So what is a problem that we are trying to solve? What are we trying to predict? Okay, say for example, we are predicting the price, we are predicting the cost of a certain object. That is called defining the problem statement. We will always start with something that we want this machine to help us to do. That is called the problem statement. So how do we get started with training this machine learning system? So first thing first is, most importantly, we need data. So where do we get the data to solve our problem? This is called data collection. So we are not stressing on collecting the data ourselves, but we ought to look for suitable data set from the internet to resolve a problem that we have in mind. Okay, so once we have the data set here, once we have collected sufficient data, what do we need to do is to explore the data set, to see if there's anything wrong with the data set. If the data set is good, to train the brain of the machine learning system. Yeah. So for example, if let's say I can just, and as a teacher, I can just take any material from the internet and then I give it to you. So is that correct? No, right? I have to do one round of checking. I have to explore the information that I have gotten before I impart that knowledge to you. So that is the purpose of data exploration. So if let's say I found that there's anything wrong about the materials, what do I do? So I will have to make some correction, and that is pre-processing steps. So before we teach the machine learning algorithm or the system using the data that is available, we will have to explore, we will have to make sure that the data is good enough to feed to the machine learning algorithm itself. And if not, we have to pre-process, make it nice before we feed it to the algorithm. That is about data exploration and pre-processing. Okay? So once we make sure that all our materials are good for consumption for the machine learning model, we then proceed to modeling. Okay? Modeling is about training the model using multiple algorithms. How do we go about to optimize it, making it to have more fit or making it more relaxed fit? This is about modeling. So once we have done the modeling, what do? We want to see that we have a set of data, we have a set of expected outcome. So then we want to evaluate how good is the machine working. How good is our machine learning model, right? Say for example, I've been teaching you knowledge, and at the end of the day, what do? How do we know that you have acquired the knowledge? So we do a test, we have exams, we have assignments, right? And that is a step of validation. So similarly, once we train the machine to do some tasks, we will also have to validate that the machine have done the work sufficiently well enough. Okay, so that is on validation before we allow this machine to make decision on behalf of us. To make decision on behalf of us means we deploy this to actual use case. All good? This is the entire machine learning workflow. So we will be spending this week going through problem statements, data collection, as well as data exploration and pre-processing. Next week onwards, we will move on to modeling, and we'll be talking about regression model for 2 weeks before going into classification for the upcoming several weeks. Okay? So, this data collection, exploration, and pre-processing is really important because that will make sure that we are feeding the right information to our training. Okay, so what did we say just now? First step, problem statement and data collection, right? Say for example, we have our first problem here, which is to predict the species of a flower. So now say for example, we have a problem. We wanted to train a machine to differentiate these flowers into 3 different species. Yeah, we have versicolor, we have setosa, we have virginica, 3 types of iris flowers. So now, how do we do that? First of all, we need to collect some information. So we have a few flowers. We collected a few flowers, and then we go about and make some measurements about the flower, about the sepal length, the sepal width, as well as the petal length and petal width. So that would be the characteristics that we want to use to predict these species. These are things that we already know, characters that we already know. Okay, so this is called a problem and a data set. So what we are going to do next is to walk through some of the vocabularies about the character of a data set. What does a data set have, and how do we choose the right data set? Okay, a right data set must consist of 4 of these characters, which we are going to go through later. Okay, so the first one, we are talking about this supervised machine learning, right? What is the most important characteristic of supervised machine learning compared to other types of machine learning? We have a target. So what is a target? Target is the category or the value that we are trying to predict. We are trying to teach the machine to learn. Okay? So in this case, this target, the target is always the dependent variable. In the case where you are familiar with statistics, yeah, dependent variable. So in this case, we mentioned that our problem is to train this machine to predict the species of iris flower. And we have a data set that consists of all of this and this, which is a table, in a table format, structured value in a table. So now, I've mentioned to you, target is a category of value that we are trying to predict. And our problem here is to predict the species of iris flower. So now tell me, which one is the target? Which one is the target? Yes, species is the target because we are trying to predict the species of the iris flower. That's right, species. I hope you are not clicking on that because you have the notes, yeah? Okay, so the next characteristic of a data set for a supervised machine learning is features. So what are features? Features are the properties of the data that is used for prediction. So say for example, we want to try to predict species of flower. So now we want to know the length of a sepal, width of the sepal, length of petal, and width of the petal. So these are some of the properties of data that can define what kind of species it is, correct? So say for example, if we have another case, we want to predict house price. What would be the features? Say we want to know where is the location, we want to know how big is the house, things like that, correct? So these are called features. So I'm going to skip that because I've just technically tell you what are the features, right? So now another important vocabulary here is called the instance or observation. What is instance and what is observation? So, and whenever we mention instance or observation, it is referring to a single data point within the data, which is usually one entire row, because one flower will have the complete set of features. That is called the instance, right? So for example, if let's say we want to predict house price, can you predict house price just based on its size itself without considering the location? No? No? We can say no, we can also say yes. It's just that how good it is, right? So whenever you add on more features to it, it will make a better prediction because it can do some trade-off between a location or a size. So now tell me, instance or observations. What makes an instance or observations? Wrong. 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 So whenever we mention instance or observation, we must refer to the entire row, okay, which includes all the features and the label itself. Okay, so that is called one instance. So how do we make sure that our data set is good enough? We must make sure that every instances have the complete set of information before we train a model. Okay? So, label. Just now we mentioned about target. We know that species is our target. So now, what is the difference between target and label? Label is the target value for a single data point. Okay? So, which one is label? Three. Yes. As long as you point to any one of this, you are right, because we want to make sure that every single observations, every set of features are tagged with its correct label. So that would, with 4 of these characteristics, with the features, with the target, making sure that every single instances have a label will help you to define whether it is a good data set for us to proceed with training a model or not. Okay, good. So there are 4 of them. So now we want to talk a little bit about the basics or the most fundamental thing on treating this data set and reading this data set. We talk about the 4 areas that we must know about a good data set for supervised learning. So now we want to talk about cleaning, data wrangling. And why is data cleaning so important? Yeah? Why is it so important? It's because our decision and analytics are driven by our data as well as our models. So before we even talk about modeling them, we have to make sure that our data is good enough. Just think about garbage in, garbage out. Our model can only be as good as our data. Say for example, if let's say you are trying to predict flower species, but you have a data set that consists of not only flowers, but also trees, leaves, grass. So is that considered a good data set for predicting the flower species? The answer is no. Okay? So we must make sure that our data is clean before we train a model. So what are some of the areas that may go wrong whenever we read our data set? So in the following slide, it is going to be a little bit technical because we are going to be a little bit technical from this point onwards. Okay? But don't worry if you couldn't follow. I'm sure that they are pretty much relates to your common sense. They are just common sense. Yeah? So first thing first, we talk about observations. What are observations? Observations refer to one row of data, right? An instance of data, usually a point or a row in a data set. So those who have already attended the practical this week, we have seen that certain rows of data have missing values. So if those are considered not clean, so if an observation is not clean within a row, what are we actually seeing or experiencing here? We are misrepresenting the examples or the relationship between the features and targets to our model. Say for example, if you still remember that one row that have an exam score of 200. So we are basically telling this machine learning algorithm that, oh hey, somebody can actually score 200 marks for a certain subject, which is incorrect. So if you are feeding the machine something that is wrong, it is definitely going to give you something that is wrong in the future. So that is about making sure every observation is good enough for our machine learning. Okay. So now, we also have to make sure that our labels is correct. Why is that so? Because the label is the one that we need this machine learning algorithm to help us predict correctly. Yeah, which is the reason why we need it to be correct. So most of the time, our data sets, they are created based on our historical knowledge. Okay, say for example, we know that this flower, this set of characteristics belongs to this flower, another set belongs to another flower. But sometimes they can be mislabeled by somebody else. Maybe just one or two. It depends on how large the amount of them are. But as a data scientist or machine learning practitioner, are we able to know whether the label is labeled correctly or not? Are we able to know that? Not so likely. Therefore, it is very important for us in the future to make sure that we work with the stakeholders to ensure that the labels are labeled correctly. So this is also one of them. In any cases where we suspect the label is incorrect, we will have to treat them or remove them from our training. Okay. So features. Features are the information that we have for each of the observations. Yeah. So say for example, there could be some information about certain features which are out. Sometimes they are just a value that is extreme. For those cases, it is easily identified. we will be using some statistical modeling or exploratory steps in order to spot these outliers, these features, okay, which are out. So then algorithms. Why are we needing to do this extensive literature review or related works? That is because algorithm also matters when it comes to training machine learning algorithm, training the system. Choosing the right algorithm will help us to produce the right thing. Say for example, today, if we want to try to predict how good is the quality of the wine, rating from 1 to 5. So we have rating of 1, rating of 2, rating of 3, 4, and 5. So what could go wrong? If we do not know this well enough, we may treat this as a regression problem because we think that 1, 2, 3, 4, 5, they are numerical, right? Instead, they are actually classes of rating. They are discrete values. So in the case where we choose a regression algorithm to solve that problem, what is the outcome? There is a potential that the output can be wrong. Okay, so that is important. Modeling. So our model will always assume that the data accurately represents a real world. Say for example, if we use a linear regression, it will always assume a linear regression between the features and our labels. Yeah. Say for example, house prices. Does it mean that the bigger is a house, the higher is a price? So a linear regression always assumes so. But it is our responsibility as the machine learning practitioner to make sure that whether they are linear or they are actually a curve. Okay? So if let's say they are a curve, then we will have to treat them a little bit differently, which we'll come to that during the regression course. Okay? All good? So what we just covered are the 5 aspects of where the data could go wrong, and therefore that should make up the first part of your assignment or of your implementation before you go into modeling. So you are going to explore whether the data sets have the complete sets of observation, label, features, and whether we are choosing the right algorithm. And then examining whether there are any erroneous value, missing values, therefore treating them before we go into modeling. So now if you are wondering, data is collected by the system, so how can they be wrong? They are put in a structured manner, and how can they be wrong? There are many ways that the data can go wrong. So the reason why data can be messy is because, first thing first, there are just too little data that is available. Okay? Sometimes too many is not the problem, but instead too little is the problem. Say for example, if let's say we want to train a machine learning algorithm to detect a very rare disease. So then, lacking of data could be a problem because the disease itself is very rare. Is that something that we can do about it? The answer is no. It just tells us that this problem is not to be resolved by a machine at this point of time until we have sufficient data. Okay? So too much data can also be a problem. Why is that so? Say for example, we want to try to predict the behavior of a customer. And now we take 20 years, we have collected our customer data for 20 years. So that is a problem of too much data. Why is that so? Because customer behavior changes over time. So the data that is 10 years before may not be relevant now, but now we are feeding this information to this brain to tell it that, oh, okay, this is actually the behavior of customer. But what we need the computer to do is to predict the current behavior. So in these instances, too much data can also be a problem. Okay, understand? And finally, bad data. So needless to say, bad data is a problem because there are just too many values that are missing here and there, collected by different people. Sometimes, in certain business process, people just input certain value for the sake of inputting it, right? Take an example, say in your process of applying for leave, you are required to fill in a lot of information, and sometimes you just fill it for the sake of filling it. So that is the source of all the bad data. We are just inputting it for the sake of inputting it, bad data. Okay? And those are some of the reasons of why data can be a problem, which is why we need to make sure that our data set is good for training to produce a good predictive outcome. Okay? So now we talk about the reason, the sources of why this data can be messy, can be wrong. So now what are the types of messy data that we have to look out for as we examine our data set? Yeah? What are the types of messy data that we have to look out for? For example, whether there are any duplicates, unnecessary data, is there any inconsistent text and typo? So those who have attended the practical, we have seen inconsistent text and typo, and we have seen how has it affect the outcome, right? So missing data is also some of them. Yeah, data sourcing issues. So many companies now, they are changing from old system to new systems. And therefore, there is a glitch between the old and the new systems. And sometimes, the way we store the information can just make things go very, very wrong. Yeah? So these are some of the types of messy data, which is very common. But two of the most important ones that we have to stress on, making sure that you know how to identify them at this level, will be missing values and outliers. And ultimately, how do we treat them? Missing values and outliers. So on missing data, there are a few policies on handling them. Whenever we face any missing values, there are three ways that we can treat them. First one is dropping them directly. We just don't want to use them. Okay. Second option is we can impute the data. What does it mean by imputing the data? Imputing the data means we will replace the missing value with something else. Say, for example, we have 1,000 customers and 5 of them has missing age. The age is missing. So what can we do? We will usually use the average of all the customers. We have 100, we have 95 values, but we are just missing of 5. We'll just take the average of 95 and then treat them as the values of the people with missing data. Yeah, imputing the data. Average is one of them. What if we have a missing categorical data? Say, for example, we have a label of whether they married or not married. So we will usually assume the missing data to have the same characteristic as the most frequently appeared value within the same data set. That is on imputation. How do we fix or fill this missing value with another value? Imputing the data. There is also another way which is more advanced, that is masking the data. So what does masking the data mean? Masking the data means just create a new value for the missing values. Yeah. So say, for example, we have a column say married, unmarried. So there are probably 50% of them is missing. We don't have a data. We don't have a data of whether they are married or unmarried. Then we'll just mask the data by saying unknown. So now instead of married, unmarried, we have another category which is unknown. So whenever the algorithm sees this unknown, it will treat it a little bit differently because we tell them that this is unknown instead of telling them that, oh, this is actually something else. Okay? So some policies of handling this missing data. So each of the ways of handling this missing data have their pros and cons. That is very important because it is us who is deciding which method to use. So removing the data is ultimately the most straightforward method and the easiest one. So what are the pros? It's quick, it's simple and easy, and it's effective. If let's say we just have less than 20% of missing data, we can just drop them because we still have a lot of other data. But what are the cons? So in the case where we are accidentally dropping the minority group that we want to predict, we are losing a part of information from removing this data from our data set. At the same time, we are also introducing bias because we are removing things that we do not want. But what if these people are actually very important and contributes to a certain level of significance in our data set? So then removing them will introduce bias to our data set, and therefore our brain can only be as good as what it receives. Yeah? So imputing the data, we mentioned about replacing that data with certain values. So the pro and the advantage of this is, yes, we preserve the data. We do not throw them. We do not lose any information. We preserve the completeness, but at the same time, we are introducing some uncertainty because this value that we are trying to impute or trying to fill are actually estimated. They are not necessarily true, but they are estimated. It depends on how good is our estimation before we impute this data. Okay, masking the data also preserve the rows and columns, but it will create another level of information where we are trying to assume that this unknown is actually helpful for us. Yeah, so there are a lot of pros and cons, and therefore it is always recommended to try to use different methods in our cleaning steps. Yeah. So what we just covered is that missing data, there are 3 ways of handling them. The most easy one is removing them, and then we can also impute them, as well as the more advanced step, masking them, giving them another meaning. Okay. So we mentioned about 2 very important data issues that we must learn how to treat. First one is missing value. Second one is outliers. So now what are outliers? Outliers are extreme value that just doesn't make sense. Okay, they are very extreme. Say for example, you have a set of people with their net worth. So a set of characteristics. And suddenly you just see that one person have a very extreme value. It could be this person just strike lottery. So that is a misrepresentation of net worth of a particular group of people within that population. Yeah, so those are called outliers. So they are very distant from others. So, and they do not, the reason why we need to treat them is because they do not accurately represent the entire phenomenon. And we just want to remove them from our training. So now how do we detect these outliers? Remember in the practical class, we mentioned about the chart type that we need to explore the distribution of data, right? Histogram. So histogram and box plot are a good plot for us to identify these outliers. So this is important because the moment I see these histograms and box plot in your assignments, I know that you are doing sufficient data exploration on the numerical columns. Okay, you are trying to make sure that there are no outliers within your data set. Okay, so now how do we detect outliers is we will use a box plot and we will usually compute the median, first quartile and third quartile. Then the outliers will be something out of the minimum and out of the maximum towards the 2 extremes. Okay, those are outliers. What are some of the policies of handling these outliers? So it is pretty similar to how we treat those missing value. First thing is removing them. Second thing is replace them with a common values, say average or median. Or just forget about them. Okay? This is how we should spot and treat outliers. And the most important part is spotting them. Okay? Are we good? Are you still with me? So, exploratory data analysis is one of the most important steps whenever we start learning machine learning, because it is just an important step before modeling. So what is EDA? Everybody must know exploratory data analysis as a short form of EDA. So it is a step where we are trying to read and summarize the main characteristics of all features in our data set. And why do we need that? It gives us a feel of how the data looks like. What are the potential relationships here and there? Okay? And the goal of this EDA must remember, because it will be important for you to deliver a quality implementation in your assignment. So the goal here of the EDA, when we talk about machine learning, is not plotting a lot of graph, it's not explaining what is the trend, but we need to make sure that the data quality is good enough. We want to determine whether the data makes sense or not. We want to identify important patterns that may impact the outcome only. Okay? So what are some of the techniques for EDA? First of all, summary statistics. Secondly, visualizations, plot, charts, graphs. And finally, what are the tools that we are going to use in Python for this EDA? Pandas, Matplotlib, and Seaborn. Okay? So, in the following slide, what I'm going to go through is some of the chart types and some sample codes that we usually use and you must know for EDA. Okay? So, first one is summary statistics. So, summary statistics is always the first thing to go to whenever we explore our data set, because it will give us the total count of observations that we have in the entire data set. It will also tell us what are the mean, standard deviation, minimum. So if your data sense is good enough, is matured enough, you will be able to spot potential outlier from this view without plotting any charts. Okay? So think about this and let's see if you can spot any outliers in this week's homework. Okay, so it takes just as simple as .describe to produce this comprehensive summary statistics. So we talk about mean, median, 25th percent quartile, 75th percent quartile of continuous features. How about those categorical features? Yes, we can also produce a summary statistic for categorical features where we want to know how many counts are there, how many unique values are there in each category, which one is the most frequently appearing one. So how does this help you in the future? Say for example, you have a missing value, you just want to impute it with the most frequently occurring category. This table will help you identify which one is the most frequently occurring one. Okay? So, we talk about histogram. Histogram is the graph for us to explore the frequency or distribution of numerical data. Scatter plots helps us to identify the relationship between two numerical data. That is important because we want to find out the most correlated features in the case of regressions. Okay? Box plot, what does it help? Box plot will help us it is a complementary to our histogram in order to help us spot the number of outliers that we may have in our data set. That is box plot. How about bar charts? So bar charts help us to identify the differences of a numerical feature between two categories. Yeah? Correlation matrix is a very helpful one, heat map, especially when it comes to regression, when we want to study which features is the most helpful one in predicting certain numerical values. Pair plots is a very advanced chart which we want to discuss in next week practical class. So make sure that you have tried out whatever that I need you to do this week. Okay? So as a summary, what we just covered is a very quick overview of how are we going to do this EDA in the future. And that is all for today's class. And I will see you next week. Next week, we are going into our first model, which is regression model. So be prepared. Do the necessary revision that you need before the next class. Okay? So those who are having practical, please stay here.